Hi everyone, welcome to this session and thank you very much for your time. Thank you for the organizers for the opportunity to be here talking to you guys. And today we're going to talk a little bit of Java in the context of AI, especially beyond the buzzwords, which is really the topic of this session. So AI beyond the buzzword, how to integrate LLMs and Java in real life. All right. First of all, I would like to get started with a few definitions just to make sure that everyone here is on the same page. So first, what is indeed the artificial intelligence? Is the machine skill to replicate the human behavior intelligence? Replicate in quotes, all right? But well, let's go forward. Second, we have the machine learning. Machine learning is the AI applied to automatically learn and improve based on previous experience. So it's a subset of artificial intelligence. Third, we have the deep learning. It's when we got a large amount of data and complex algorithms and use them to train models using neural networks. And then finally, we have what we call the generative AI. It's what have make everyone excited about AI in the last few years. It's when we use all of it to generate new and original content. Okay, so it's applying all these technologies to generate new content, right? And involved in all this generative AI stuff, we have the LLMs, what we call the large language models. LLMs, they are trained from a huge amount of data, usually trillions of tokens. And what are tokens, since we are talking about it? Token, it's a small chunk of text. Can be the word or a part of word or even a character of a word. And the module usually use these tokens to read and to process these tokens in order to generate new content. And the modules, they break the sentence into tokens in order to understand and to generate language step by step. And also, it will create a vectorized relationship among characters, word, and sentence in order to have this semantic stuff being processed by the modules. Usually they are optimized for some specific domains, although we are used to these huge modules that we've been using, like ChatGPT, that is using the GPT. We have the Gemini, we have the Claude, this is using Opus and the other models behind of it. So these big modules that we have in the market, they are not so specialized, but we can have more specialized modules, okay? Of course, we are kind of serious on using this stuff since we are intend to use modules to our jobs, to our projects, to do our work, but some people are not that serious about it, like this guy here who asked ChatGPT to write a poem so he or she can lie to not attend to a meeting. So you can pause and read this poem if you can. But there are some other questionable uses of AI, as this article from the American Urological Association journal. And in the end of the article, we could read that the utilization of ChatGPT in urology has a high likelihood of facilitating medical misinformation for the untrained user. So I'm guessing what people are asking to the AI in these days. Also, never mind. But seriously, let's take it to the step when we can use AI to do our jobs with more productivity, especially to integrate our Java projects to AI in the serious and correct way. Okay. In fact, the modules, they are useless for enterprise application if you can't integrate them to existing workloads. We as Java developers, we use it to work with huge workloads. We have a lot of projects already running production. We have a lot of Java code running production. So our main target when we look to AI is not only how to be more productive, but how to integrate our code that is already running into AI. And that's why we are talking here today about LangChain4j. LangChain4j is the main project that we can see in the industry today in order to integrate Java with LLMs. What is LangChain4j? First is unified APIs, because if you look to each of the LLMs that we have in the market, each embedded store, each vector databases, they have their own APIs, they have their own way of integration, and LangChain4j will abstract this complexity for you and do this bridge between your Java code and those solutions that we have on the market today. Second, they have an approach that we call it ready to use. So for prompt templating, for memory management, for tools calling, for RAGs, the retrieval augmented generation, whatever they can give to you ready to use, they will do. They have annotations, they have interface, and a lot of implementations that you can go ahead and use. Also, they have what they call the easy RAG. It's a super simple RAG implementation, in memory RAG implementation, that you can just point your folders with your documents and so on, so you can have your RAG up and running really fast, especially for POCs, for simple projects. You can use it right away. Of course, if you need more complex RAG implementation, they have the solution for it. But for getting started, the easy RAG is super simple, and I will show you in a few minutes. Agentic AI, of course, everything about AI today is about agentic. So they have the whole support for agentic AI that we are also gonna see in a few minutes. The MCP, the standard for integration in a loosely coupled way, where you can integrate your agents with whatever kind of resources like documents, databases, even with legacy code, you can do it by using the MCP. And the 4J, because Java is fun, that's why we are here, and we really believe that Java ecosystem is ready to go to integrate with AI, and the LangChain4j is our main hub for it today. And besides the integration with the modules, of course, when we are talking about Java, it's not uncommon to talk about frameworks. And when we think about frameworks in Java, we need to rely on a framework that will ease your way to production, especially for distributed application. And in this case, we'll cover here Quarkus. If you don't know about Quarkus, if you're not using Quarkus, I will just explore very briefly here. First, the main approach of Quarkus is what we call the developer joy. So it's a cohesive platform for optimized developer joy with unified configuration and no hassle native executable generation. So you can, whatever you have inside Quarkus is already ready to use with native compilation with GraalVM and so on. Performance, so Quarkus is made for performance, so it will make optimizations for all the build phases and the runtime, so you can reduce the dependencies and improve efficiency. Everything in Quarkus is made for Kubernetes, so we went beyond just the cloud native, and we made the framework that we call the Kubernetes native. So whatever that we have on Quarkus is ready to run on Kubernetes. And because we are doing stuff to work on Kubernetes, we are also doing everything in a container first approach. So everything is done to work with containers. And of course, we truly believe on the community and the standards. So everything inside Quarkus, it's following the standards and sustained and moved by the community. Here we have some stories. We have tons of them. Here you can see the link in the bottom of this slide, but you have some examples here, like Orange, like Banco do Brasil here in Brazil, Lufthansa, and Wipro, and so on. And we are also supporting the best of breed libraries inside Quarkus. So if you are using Hibernate, if you are using Microprofile, if you are using other projects, open source projects, Kubernetes, and so on, even Spring, if you are a Spring developer, a lot of Spring libraries are already supported on Quarkus, so you can keep using, you can keep writing your same Spring code and use Quarkus with the performance optimization and so on, the Kubernetes native and native compilation and so on. So we are supporting all this ecosystem under Quarkus. Okay, let's move to the demo time. And I hope that the demo gods are not so angry today. I have especially 4 demos that I will show you in a few minutes. And let's move to our IDE here. So the first one we'll cover here are the prompts. So let's move to the IntelliJ. And here for this first one, I will show you how to create your first Java AI assistant code. So you basically need 2 stuff here. The first, your assistant. And your assistant will be simple as that. It's an interface with a name, with a method. This method will return some kind of string, can be other kind of data, but it will start with string. It will receive the message because this message will be sent to the module, and it will annotate this interface with this register AI service. Okay, and the second stuff, of course, our endpoint, where we will inject our assistant, and here we have a simple get method that will get the message and send to the assistant, and then get it back on the prompt. And just for the sake of properties, here we are connecting to a GPT-OSS 120B. In here I'm using the Ollama cloud. Okay, and here the timeout, and don't worry about it, I will show you in a few minutes. So I will here start my Ollama server. Ollama serve. Okay, so actually I'm not really using a local module. I could, but I'm not using. This local Ollama will be just working as a proxy to the cloud modules on Ollama. And let's start this application here. Mvn clean Quarkus dev. So let's start the application. Okay, so right now we are connected. Let's go to the browser so I can hear. Okay, so this is our application. It's up and running. If you never saw the dashboard of Quarkus, this is the the landing page of our dashboard. I will not cover everything here because we don't have time, but we can see the extensions, we can see all the configuration, we can see our workspace, all endpoints, we can cover all tests here, the dev service that will emulate some service locally. Here all the metrics, and here the map of our dependencies. But let's move here to I have the Open API in this project, so I can access the Swagger, and here I have all the endpoints. The first one is the simplest one, is our first prompt. So actually I can just ask whatever I want to this module. So I can, for example, tell me about Java the programming language. Okay, so let's ask the module, and at this time I'm accessing the GPT OSS 120B on cloud on Olema Cloud. Okay, so it's now building my my response. Let's wait a little bit. All right, so here's the answer. Let me do a zoom here. So Java an overview is a high-level class-based object-oriented. So here's the whole story accordingly to this model that we are using. I'm not read every data here, but just to let you know that this is the answer that we got from the module. So to send this prompt to the module and to get this answer, we only needed these two classes. This class with the endpoint and here with the prompt. And of course, here I can ask whatever I want. I can ask, for example, tell me about Microsoft. Okay, and then we'll keep doing whatever I ask here to the module. All right. So this is our first and simplest example on how to build your first chat with using LangChain4j and Quarkus. Second, memory management. So when we are using, for example, ChatGPT, then you ask a question, it answers you, then you ask a question again, and it answers you again, and you have this feeling that the memory is keeping going on the conversation. This is managed by the application layer, not by the module layer, because the module doesn't have any kind of memory. Every prompt that you send to the module is a new conversation, is a new prompt. So all the memory, the conversation memory is managed by the application, and that's what I'm gonna show you right now, how to do it using LangChain4j. So let's go here to the memory. Here we have another assistant. I just separated for the sake of this conversation here for you, but we have a new stuff here. We have the memory ID. So we can, for example, separate the session that we are keeping this conversation. We can use whatever ID, whatever we would like to use to have a conversation being managed by LangChain4j. We can use, for example, chat memory ID. Under the hood, if we are not using this, LangChain4j has its own ways of doing it. I'm just using this example to make it more visible for you. But of course, you can use the way the LangChain4j is doing it for you. And here I have this guy here. There's another endpoint. So I have two examples. The first one is the memory. So for example, how do I write a REST endpoint in Java using Quarkus? I have this message, and I will send this message to the LLM here, and I will get this first response. And then in my second message, I will ask it to create a test based on the first step, and I will send another message. But here I'm keeping the ID of the conversation the same. So it will understand that we are following up in the same conversation, and hopefully it will answer us in the same context. So let's move here to this guy here. And this is the memory. Yes, memory. So this is the memory. Try out. Here we don't have prompts because the prompt is inside the endpoint is just for the sake of the example. So let's wait for the module to give us the answer. Okay, so here is the answer. How do I write a REST endpoint in Java using Quarkus? Below is a step-by-step. So what do you need your machine, the tools and whatever, the tip, bootstrap application, the CLI and everything. So it's a very complete answer, I need to say. To create the application and REST is reactive and so on. So here using Maven, and the project structure, how to open, how to write, here's the code. And well, we have here the full implementation of this REST endpoint using Quarkus. So this is the answer of this endpoint. And we have our it's went ahead and wrote the test. Okay, that's fine, because on the second part I will ask him to write the test. And let's go. Okay, so here is the second prompt: create a test for the first step, be short, 15 lines code maximum. It already wrote the test, but that's fine, okay, because we never know. And that's one aspect of when you are dealing with AI, you're never so sure of the response. Of course, you can make it more predictable in terms of your prompts. If you improve your prompts, the response could be more predictable, but we are dealing with stuff that are not that predictable. So here we have the test, and of course looks like it's fine. Okay, so this is the second. The third is the chatbot and embedding. So now let's move to another project here. Oh no, I will keep in this because I will go to the fourth. Then we move to the project. Okay. The third, that should be the fourth, is the tools and agents. How can we use LangChain4j with your Java code to do what we call tool calling in the AI space? So here we have another assistant, and here we have some new stuff. We have first two kind of prompts here. We have the system message, we have the user message. The system message is when we define the behavior of this AI service. So how it will really behave, okay? So you are a professional poet. When I talk this to the module will set the context of working. So you set the tokens that we consider for the job, the task that we do. And here we have what we call a prompt templating. So I don't have a full prompt here. I have this template, and then I will send some parameters to them. So I will, for example, write a poem about topic. So I will just send the topic. The poem should be lines long. Send this poem by email. And here's the thing. The module can write a poem, but the module itself can't send email because it's not an email server. It doesn't have an email server. So how can I ask it to send email this poem by email? Because I am exposing what we call a tool. And you can see here that we have a list of tools, and I'm defining here as an email service. And this email service is this. So I define a simple class, a simple annotation, application scoped. Here I have a mailer being injected, but this method is annotated with this annotation at tool. And here I'm saying, hey, send this given content by email. And here I have my send an email code. So yes, the module can send email, but I can tell it, hey, I have this method, I have this tool, and this tool can send email. So if you are saying that you should send email, you can just call this tool and send the parameters, and this tool will send email for you. And I can do it for whatever I would like to. Okay, so that's how here we'll send an email. And the endpoint is simple as it. Okay, so just then the topic and the number of lines. So let's test this code here. So email me a poem. Try out. So I have a poem. I would like a poem with 5 lines about Java, AI, and Microsoft. for example. So let's see what kind of poem it will write for us. So here I have the poem. From Java's steaming code we forge the night. AI's whisper learns each silent bite. Microsoft Cloud cradles dreams in the sky. Together they compose a future night, a symphony of silicon thought and light. And well, whatever. And this poem, if I was connected to the email service, it would be sent by the tool, using the tool to send it to the destination and whatever. Okay. So now, yes, let's stop this application and let's switch to the other one. We are just finishing this session in a few minutes, and here we will talk a little bit about RAG and embedding. So here's the thing. How can I make the LLM give me answers based on my business, based on the policies of my business? One of the approaches that we can use is using RAG. So here, what do we have? I'm using the same module, but as I told you in the session, we are using here the EasyRag extension, and basically we are pointing a folder, and this folder we can have whatever kind of documents we would like, and here I have the policies of my car rental company. So here basically we have the terms of use of my car rental company. I will not read it for you, okay? You can see. Oh, and by the way, in the end of the session, I'll give you an URL when you can have all the source code and the slides of this session. Here we have the assistant. When in the system message, I'm defining the behavior. Hey, you are a customer support agent of a car rental company and so on. So I'm defining whatever it needs to do its job. I have the tools, as I just told you. I have one method annotated to get the details of a booking, and another method annotated to cancel a booking. Everything here is implemented using WebSocket. So here we have the chat socket. Okay. So let's open. Let's see. Here we have the chat assistant, HTML, localhost, chat assistant. So here is our page. I want to cancel a booking. So it will ask me the booking number and the first name and surname. Elder Moraes, 1, 2, 3, 4, 5, 6. Let's see if they find my reservation. I'm sorry, but I couldn't locate. Oh, yes, the name is not Elder Moraes, it's John. It's John Doe. John Doe. Doe. And the number, yes, is 1, 2, 3, 4, 5, 6. And here this thing, I'm just using natural language with it. So there's nothing really, there's no code related to this support stuff here. We are just using the policies of our business and just accessing some kind of database with the orders or the reservations and so on. So this is the way that AI will let you to really, and here is really productivity. So we can focus more on the way that our agent will deal with the customer instead of just creating specific code for giving this kind of support. Okay, so these are our examples. If you would like to get the all the code and the slides of this session, you can just access this QR code or this URL, elder.moraes/Quarkus-LangChain4j-n. And if you would like to know more about Quarkus and AI, we have a full web page about it. So quarkus.io/AI, and also the QR code here. All right. So thank you very much for the opportunity. Thanks again, Microsoft, for this opportunity to be here. And thank you that was watching this session. And see you next time. Bye-bye.